and seconds. And I told you that that was another way of measuring angles to get an accurate measurement outside of just having decimals. So, if we have degrees, minutes, and seconds, so I'm just going to kind of run through a scenario and explain. Okay, so I wrote out steps on your notes, and it says if I want to change this to a decimal, the degree part doesn't change, so it's still going to be 5 degrees. But then I have to convert these. So 12 minutes, how many minutes are in a degree?
60.
So we would have to convert that into a decimal, do 12 divided by 60. Let's talk about the seconds. There's 23 seconds. But I need to change that into a decimal degree. How many seconds are in 1 degree?
3,600.
Right, because there's 60 seconds in a minute, 60 minutes in a degree. So 60 times 60 is 3,600. And then you're just going to add those together to get your decimal. So I would put it all in at once so you don't have rounding error. So we have 12 over 60 plus 23 over 3,600. And we get 5.2064 degrees, or depending on how many decimal places you wanted to get.
I didn't round up yet. Or I didn't add the 5.
So that's the process that is spelled out on your notes handout. Leave the degree the same, divide the minutes by 60 because 1 degree is 60 minutes, divide the seconds by 3,600 because 1 degree is 3,600 seconds, and then we add them together. Okay, so if we look at so if I wanted to change this to decimal degrees, my degree part stays. To get my decimal, and you're welcome, like some people just like to write it all out, that's fine. How many minutes are in a degree?
60.
So we have 105 plus 20 over 60, 32 seconds, so that would be divided by, and if we put that in, nearest thousandth is 3 decimal places. So 105.342 degrees. You can, but since I said to round to the nearest thousandth, you don't have to. Alright. Is that okay?
The soft rumble of the computer.
So let's talk about going the other way. If I have this decimal, how do I go back and get the minutes and seconds? So if you think about it, we got the decimal by dividing. So to go backwards, we would multiply. Opposite of multiplying, or opposite of dividing is multiplying. Okay. So the degree part won't change. Then we'll take our decimal times 60. So if I said like 20.314 degrees. So my decimal, 0.314 times 60. And that gives me 18.84. This is minutes. So we currently have 20 degrees, 18.84 minutes. So that's 18 minutes. Now, to change this decimal into seconds, we actually just multiply it by 60 again. So we take the decimal from our minutes. Since there's 60 seconds in a minute, we take it times 60. And then this one, we round to the nearest second. So it would be 20 degrees, 18 minutes, 50 seconds. So that's the process here. Multiply the decimal by 60. The whole number part is your number of minutes. Multiply the new decimal by 60, and you get your seconds. So if we do this one, we have 85 degrees to get the minutes. We do 0.263 times 60. That's 15.78. So we're not rounding that yet. We're just saying that means we have 15 minutes. So then to get seconds, we take that decimal times 60.
46.8.
And if I want to round that to the nearest second, what would I do? 47 seconds. So I want you guys to try example 6 then. Let's see how.
Since but I could just take guys' content, fine.
All right, so first one, we get 74 nearest thousandth is 3 decimal places, so 0.137 degrees.
I keep forgetting to add degrees.
Yes, keep your degree symbol. B, we have 34 degrees, and then we do 0.817 times 60. So 49.02. So we take that part, no rounding involved there, just 49 minutes, and then we take our decimal times 60 to get our seconds. And this one you do round as needed, so it would just be 1 second, or you could say 0.1 seconds. Did everybody get that? Looks like we did pretty well. Okay, then we have a few more terminology pieces to hit. Coterminal is going to be very, very important to us. Coterminal are angles that lie in the same position. To find them, we add or subtract 360 as many times as needed to obtain an angle with a measure greater than 0 but less than 360. So here's what I mean. When we talk about angles, we are going to want something between 0 and 360. 360 degrees is a whole circle, so that would take us all the way around back where we started, right? But if I had an angle, say like this, okay, I could tell you this is maybe a 45-degree angle. But there are other angles that would also lie in the same spot. We talked about yesterday how this line was important because if I spun this way, what kind of angle would that be? A negative, so I might say negative 315 degrees. Now for most people, seeing a negative 315 is a little harder to visualize than seeing a positive 45. So what we would do in this case, if you don't want that negative, you just add 360 to make it a positive. Okay? But it could be, like, maybe I go around the circle 2 times. If I go around twice, how many degrees have I traveled?
Negative 330. Or negative 630, or 90.
Well, all the way around is
oh,
360.
Sorry.
So 720 degrees would take us all the way around, or negative, depending on which way I spun. But we probably don't want to talk about 720 degrees. It would be easier to say, oh, that's 360. Or 0. So if I give you a really, really big number or a negative number, you can add or subtract 360 to get that more manageable coterminal.
What if it is 0? Like, what if the answer comes out to be 0?
So to draw a 0, we're going to talk. Let me do this next definition and then I'll explain that. So a standard position is how we are going to draw all of our angles. So that means you have an angle with a vertex at the origin. What do I mean by the origin?
Where the lines intersect, 0, 0.
There's the origin. The initial side, so that's the starting side, is on the positive x-axis. And then the terminal side would be wherever it happened to end. So in that case, a 0-degree angle would look like this. The beginning and ending side are the same. So you just get that right. If I drew it like that, what would the measure of that angle be? 360, because I went all the way around. So 0 and 360, they end in the same spot. The only difference is that line that I drew. Or if I drew like this, how many times did I go around?
720.
720. So if you want to show a bigger angle, you can draw your line looping around. Okay. Quadrantal angles are angles that end on a quadrant break. Okay, so on an XY axis. So we know this one, that's 0 degrees. If I drew an angle that started here and ended here, what's that measure?
90.
If I drew one that started here and ended here,
180.
that's 180 degrees. If I went from here to here, so those are your quadrantal. Or if I go all the way around 360. So if it ends on an X or Y axis, it's those multiples of 90. Those are considered quadrantal angles. Okay, so let's practice finding a coterminal angle just to make sure we understand what I mean by that. So coterminal, remember, it ends in the same spot. It's the same position. We're just looking at a more reasonable number. So if I said 1,106 degrees, we typically want an angle between 0 and 360. So what would I need to do? Subtract 360. Okay, is that small enough? Nope, so you subtract 360 again. Is that small enough?
Nope.
So we subtract 360 one more time, and what do you get?
26.
So 26 degrees. Okay, do we have a visual of what 26 degrees would look like if I asked you to draw it? So start here. We know this line represents 90, so 26 would be here. So this is 26. How is 1,106 different? It went around 3 times and came back. What quadrant did this angle end in?
First,
Quadrant 1. You remember your quadrants? 1.
first, second, third, fourth.
Okay, so I could ask you what quadrant it was in. All right. B. Negative 150. Okay, it's a negative, so you would add 360. And what's that give us?
210.
Right, so if I asked you to draw that, I didn't, but I could. Standard position. This is 90, 180, so 210 would be a little bit further. So that's 210 degrees. If I drew the negative 150, what's the difference? Yeah, it would have been drawn like this. That's the negative 150. So it ends the same spot, just a difference in perspective. Which quadrant is that one in? C. Negative 603. Add 360. How many times?
Twice.
And what do we get?
117.
What quadrant would 117 degrees be in?
Second.
And so it's between 90 and 180, so be in the second quadrant. Alright. Any questions with this?
Would our arrow would always be going
Um,
clockwise?
if you draw the final coterminal angle, yes. Now, if you drew the original, then that would have been going the other direction. Last thing in this section is just kind of beginning some conversions. We're going to have these pop up. We won't really do a lot of them until chapter 3, but I just try to throw them in when I can. So a wheel makes 270 revolutions per minute. What does that mean? A revolution is all the way around, right? So it will go around 270 times a minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? Okay. There are different ways of doing this problem. Some people can just think through this and they know exactly what to do, and that's fine. I try to start now kind of setting them up for unit conversions, just so when we get into more complex problems later on, we kind of have a method established. If you do it a different way, I don't care, as long as you can explain to me and show me enough work to justify what you're doing. So we are traveling 270 revolutions per, means divided by, a minute. First thing, I need degrees. So we need to multiply this by something, and I want to get rid of my revolutions. So think about, if you want something to cancel, it has to be on top and bottom, right? So since revolutions is on the top, to cancel it, it needs to be on the bottom, and we want degrees. So we know 1 revolution is all the way around the circle, and how many degrees is all the way around the circle? 360. Have you guys done unit conversions like this in your science classes?
Yes.
Okay, so that would give me the degrees. And then I went for 5 seconds. So right now I'm in minutes, so I need to change my minutes. Minutes is on the bottom, so to cancel it, it needs to be on top, and we want seconds. 1 minute is,
60 seconds.
okay. And how long is this spinning?
5 seconds.
5 seconds. So this isn't a conversion, we're just using the number given in the problem. So that will cancel my seconds. So at the end, the only unit we have left is degrees, which is what it wanted. It said how many degrees. So we need to do 270 times 360 times 5, and we need to divide by 60. So it will travel 8,100 degrees in 5 seconds.
That's not the number I would have guessed.
Not an obvious guess. Why don't you guys try the next one? So 480 revolutions per minute. We need degrees, so we have to cancel the revolutions. So 1 revolution is 360 degrees. Because I said seconds, we have to change my minutes. What if I said 2 minutes?
120 seconds.
We wouldn't even have to. If this had been minutes, we could have just said times 2 minutes. But because my units are different, I have to convert. 1 minute is 60 seconds. And I have to put the minutes on top, so the top and bottom cancel. And then we have 2 seconds. So 480 times 360 times 2 divided by 60. Is that all right? So that is the end of this section. Yesterday I gave you, what did I tell you? You could go up through 45. Is that our break?
30, yeah.
45. Okay, so now you can finish it.